Okay, let's continue our discussion about operations on rational expressions. Okay, let's proceed with addition and subtraction of rational expressions. So, in addition and subtraction, we consider two types of fraction. We have the similar and dissimilar fractions. What is the difference between the two? For similar fractions, they have the same denominator. And if they are not, it is called as dissimilar fractions. So how do we add or subtract similar fractions? If we have similar fractions, all you have to do is to add or subtract the numerator, then copy the denominator. For instance, we have there 2/3 plus 5/3. So again, you just have to add the numerator and then copy the denominator. So we have 2 plus 5, that is 7. Then copy over 3. So we have the final answer of 7 over 3. Now for the similar fractions, we have there 1/2 and 5 over 3. So the answer is 13 over 6. How did we come up with an answer of 13 over 6? First is we look for the LCM or the LCD of 2 and 3. Then we divide and then multiply. So I will explain it to you later on. How did we come up with 13 over 6? Okay, so let me explain it to you further using this example number 8. We have 4x over 5 plus 3y over 5. Add 4x over 5 and 3y plus 5. Now, as you can see, we have similar fractions since they have the same denominator. So all you have to do is to add the numerator and then copy the denominator. So as you can see, 4x and 3y are not similar terms. Therefore, we cannot combine that. So what we will do is to copy 4x plus 3y all over. Again, they are similar fractions, so copy denominator. And that will be our final answer. Let's have the next example. Okay, so let's try out more complex example. So we have there c squared over c minus 2 minus 4 over c minus 2. Now, as you can see, we have the same denominator. So all we have to do is to subtract c squared minus 4 and then copy the denominator. So we have c squared minus 4 all over the same. So copy c minus 2. Okay, so how can we simplify this rational expression? As you can see, we have there c squared minus 4. This is factorable. So let's get first the factors so we can simplify this. C squared minus 4. Common factors of negative 4. That is positive 2 and negative 2. So we have c minus 2 and c plus 2. Okay, so let's write that down. Factors of c squared minus 4 is this one, c minus 2 times c plus 2 all over c minus 2. Now, as you can see, after getting the factors, you can now notice that we have common factors. So all we have to do is to cancel that out, and we are left with c plus 2. So c plus 2 will be our final answer. Let's run example number 10. Okay, so let's have the last example for similar fractions. As you can see, we have the same denominator. So let's start. We have x squared. We have x squared plus 7x plus 3. Our operation is subtraction, so minus 2x plus 3. Now, you might be confused, or some of you might remember when subtracting polynomials, we have to change the sign of our subtrahend. That is the first thing that you should do before we simplify. So we have all over x plus 4 times x plus 5. Okay, so let's change the sign of 2x plus 3. So we have x squared plus 7x plus 3. Negative times 2x, that is negative 2x. Negative times positive 3, that is negative 3. All over x plus 4 times x plus 5. Now simplify. As you can see, we have common terms, 7x and negative 2x. So we have x squared. 7x minus 2x, that is 5x. Next, constant term, positive 3 minus 3, that is 0. So you don't need to put here 0. All over x plus 4 over x plus 5. Now, do you think this is the final answer? Okay, that's correct. This is not yet the final answer. Why? As you can see in our numerator, we have x squared plus 5x, which has common factor, and that is x. So what we will do is we have to factor that out, factoring by GCF. Common factor is x. Then what's left? The first term is x plus factor. We are left with 5 all over x plus 4 times x plus 5. Now, as you can see, we have common terms, and we can cancel that out, and we are left with x over x plus 4. And this is our final answer. So how about the similar fractions? So before we proceed with example number 11, let me explain to you how to perform operations with the similar fractions. We have the similar fractions or different denominators. From my previous slide, we have their 1/2 plus 5 over 3. How did I come up with an answer of 13 over 6? That's the question. So if you encounter fractions with different denominator, the first thing that you should do is to get the LCD. LCD stands for the least common denominator. Okay, how can we find out the least common denominator? In basic mathematics, you take out the denominators and get its multiple. Now, the number with the least common, that will be our LCD. So let's try this one out. The denominators are 2 and 3. So multiples, that is 2, 4, 6, 8, 10, 12, 14, and so on and so forth. Now for 3, we have 3, 6, 9, 12, 15, 18, 21, and so on and so forth. Now, as you can see, we have their common multiples, that is 6 and 12. Now, which among this is our LCD? Of course, LCD stands for the least, therefore, the LCD that we are talking about is 6. So, LCD will be our overall denominator. So, next, so that is over 6. Next, what's next? 6 and then 2. You have to divide that. 6 divided by 2, that is 3. Then 3 times 1 is 3. Copy the operation, plus. You will do the same on the other side. 6 divided by 3, that is 2. 2 times 5 is 10, so we have 10. Now simplify. 3 plus 10 is 13 over 6. Since they don't have common factors, then this is our final answer. That's why we came up with an answer with this. Okay, so let's try 3n over 4n plus 5m over 6n. So as you can see, we have different denominators. So the first thing that you should do is to get the LCD. Okay, for the LCD, we have 4n and 6n. Get its multiples, we have 4n, 8n, 12n, 16n, and so on and so forth. For 6, we have 6n, 12n, 18n, and so on and so forth. Now, as you can see, we have there the least common, then that will be our LCD, which is 12n. Now, since our LCD is 12n, that will be our overall denominator. So, we have 12n. Next is to divide. So, divide 12 divided by 4, that is 3, and divided by n is 0. So, we have 12, again 12 divided by 4, that is 3. 3 times 3, we have 9. 9m. Plus, let's do the same on the other side. 12n divided by 6n, that is 2. 2 times 5n, that is 10. 10n. Now, since they are the same or similar term, we can combine that one. So, we have 9m plus 10n, that is 19n, all over 12n. Now, that will be our final answer. Okay, so let me introduce to you another option that you can use in simplifying this expression. So, this is my technique when I was in high school. So, we all know that our LCD is 12n, that is given. So, what is my other option? So, we have 3n. We have 3n over 4n plus 5n over 6n. Now, what's next is that for this one, I have here 6. I will multiply this fraction with 6. And then on the other side, I have there 4. So I will multiply this with 4. And then we will come up with the same answer. Okay, so let's proceed. So 6 times 3, that is 18n, all over 24n, plus 5 times 4 is 20n, all over 24n. Now simplify. Since they are just the same, copy. This is a similar fraction. Then, we have common terms, 18n plus 20n. That is equal to 38n all over 24n. Now, let's simplify. 38 and 24 shares the same factors. 38 is 2 times 19 and 24 is 2 times 12. So, since they have common factors, we can cancel that out. And we are left with n, 19n, all over 12n. And that is the same with our answer a while ago. So again, this is another option. If you got a little bit confused, you can still use the option number 1. Another example number 12. Let's have another example, 4 over x minus 3 over x plus 3. Now, they are the similar fractions, so the next step that we should do is to get the LCD or the LCM. So since x and x plus 3 doesn't have any common multiple, since this is a monomial and this is a binomial, therefore our LCD is x and x plus 3. That means our overall denominator is x and x plus 3. Okay, so next is to divide, then multiply. So x times x plus 3 divided by x, cancel out. We have 4 times x plus 3. Minus this one. We are left with x. X times 3, we have 3x. Now simplify. We have, kind of distribute 4 with x plus 3. We have 4x plus 12 minus 3x. All over x times x plus 3. Combine similar terms, we have x plus 12 all over x times x plus 3. Do they share common factors? There is no common factor, therefore this is our final answer. Or you can make this one as x plus 12 all over x squared plus 3x. The option is that you have 4 over x minus 3 over x plus 3. Again, I can multiply this with x plus 3 and this one with x. Okay, so we have here x plus 3 times 4 all over the denominator. We have x times x plus 3. minus 3 times x, we have 3x, all over x plus 3 times x. So simplify, we have 4x plus 12 minus 3x all over x times x plus 3. Okay, let's continue. 4x minus 3x, we have x plus 12 all over x times x plus 3. Again, our answer is still the same with our answer a while ago. So again, different process, but the same answer. Now, which one shall you use? It's up to you. Okay, for the last and final example, example number 13. Let's try another example. So as you can see, they are different. I mean, the denominators are different. So the first thing that you should do is to get the common multiples. But as you can see, this is too complex since we have different trinomials. So what is the next step? First is you have to factor out this denominator, m squared plus 7m plus 10, and m squared plus 5m plus 6. Okay, so let's get it done. M squared plus 7m plus 10. Factors of 10, that is 2 times 5. 2 plus 5 is 7. So this is the correct factors. Next, 4m squared plus 5m plus 6. Factors of 6. 6 is 6 and 1. 6 times 1 is 6. 6 plus no. This should be 2 and 3. Right? 2 times 3 is 6. 2 plus 3 is 5. So the factors that we are looking for is m plus 2 and m plus 3. M plus 3. So this is 4 all over. The factors are m plus 5 times m plus 2. Plus, we have m minus 1. The factors of this are m plus 2 and m plus 3. Now, going back with our problem, we do not have LCD since our denominators are too complex. That's why we get the factors. So the LCD or the denominators are m plus 5, m plus 2, m plus 2, and m plus 3. But since this is just the same, this is common, therefore, the LCD will be m plus 5, m plus 2, and m plus 3. So our overall denominator will be m plus 5 times m plus 2 plus m plus 3. Okay, next. This one and this one, divide. Of course, when we divide, common factors will be cancelled out. So this will be cancelled out. We are left with m plus 3. So we have 4 times, sorry about that, m plus 3. Plus, let's have this one, m plus 2 and m plus 3. So m plus 2 and m plus 3 will be cancelled out. Then we are left with m plus 5. So we have m minus 1 times m plus 5. Okay. So next, let's simplify. We have 4. Kindly distribute this. We have 4n plus 12 plus this one. Let's multiply two binomials. Now you can use FOIL method if you want. We have m squared plus 5m minus n minus 5. If you can remember how to multiply two binomials, kindly look at my previous videos. I have multiple or tons of examples there. All over n plus 5 times n plus 2 and n plus 3. Okay, next. Simplify by combining similar terms. we have m squared as the leading coefficient. 4m plus 5m, that is 9m minus m, so we have 8m. Next, 12 minus 5, that is 7. All over m plus 5, m plus 2 times m plus 3. Now, is this the final answer? Let's try to figure out. Of course, in simplifying rational expression, you have to cancel out common factors, right? So in this case, since we have m squared plus 8m plus 7, which is factorable, let's try to figure out the factors if we can still cancel out terms. Okay, so let's see. We have m squared plus 8m plus 7. Factors of 7, we have 7 times 1. 7 times 1 is 7. 7 plus 1 is 8. So this is the correct factors. Now, is there any common factors with our denominator? None, right? So since there are no common factors with our numerator and denominator, therefore this is our final answer. Now, some of your professors might tell you this is not yet the final answer. You have to simplify this one. Then you multiply this one. Okay, so that's it. Okay, that's it. That's the end of the video for the key concepts of rational functions. And actually, that is the first part about rational expressions. So I hope you learned a lot from this video, and I hope to see you again the next time. Bye, and God bless everyone.